Most of us remember reading about Archimedes, the famous Greek mathematician. It was Archimedes who postulated that an object, wholly or partially immersed in water, is buoyed up by a force equal to the weight of the water it displaces. Now let's see. Objects wholly or partially immersed in water. Now wait a minute. As divers, that would be us. What has come to be known as Archimedes Principle is something that affects us every time we get in the water. As divers, we're chiefly concerned with the three states of buoyancy: positive, negative, and neutral. An object such as a dive boat, which is relatively hollow and displaces far more water than it weighs, floats and is said to be positively buoyant. A heavy, dense object, such as a lead weight, displaces far less water than it weighs and sinks, making it negatively buoyant. An object like a submarine, on the other hand, which can be made to displace precisely its own weight in water, neither floats nor sinks, and is said to be neutrally buoyant. As divers, there are times when we want to achieve each of the three different states of buoyancy. For example, when resting or swimming at the surface, we want to be positively buoyant, so that we don't have to struggle to stay there. When initiating a descent, we want to be slightly negative, so that we don't have to fight to get down. Most of the time, however, what we want to be as divers is neutrally buoyant. Neutral buoyancy allows us to hover motionless at any depth. It also allows us to swim underwater with the least possible effort. Being neutrally buoyant not only makes diving easier, safer, and more enjoyable, it helps us avoid contact with the bottom, and thus helps us protect the fragile aquatic environment. In the section on diving equipment, you'll learn more about the items we use to help us control our buoyancy in and under the water. In the section on diving skills, you'll learn about techniques such as proper weighting, BC use, and breath control, which allow us to achieve any state of buoyancy we want. There's one more thing you need to understand about the physics that govern buoyancy control. Because it contains more dissolved minerals, salt water weighs about 2.5% more than an equal volume of fresh water. This explains why objects are more buoyant in salt water than they are in fresh. It also explains why you'll need to wear more weight to be neutrally buoyant in salt water than you would while wearing the exact same equipment in fresh water.